Hi students, and welcome to today's live IELTS class. My name is Adrian, and I am streaming to you very near the Danube River in Central Europe. I hope everybody is having a great day so far, or has had a great day if it's late in your country. Hi Joel, hi Virus Active, hi Libyan, Mandeep, Jas. Students, this is an IELTS reading practice for Band 9 class. We will be looking at a passage 3 for the academic IELTS. If you're a general student, challenge yourself. If you can do this, you can definitely do the general version of the exam. Hi Pradeep Padu, good to see a member in class. Students, the materials, this passage is coming from our first exam book, second exam, passage 3. We have 6 original practice exams, fully interactive course, and over 100 hours of video lessons. Check us out at aehelp.com. That's academicenglishhelp.com. Or check us out at gieltshelp.com for the general version of the exam. I'll quickly show you what those websites look like. This is the fuel for our knowledge that we provide to the world. This is our aehelp.com website. You can join by clicking that big red button. You get a My Student account, and you can access your materials from your phone, tablet, PC. This is the general with the green background. Click that red button to join there. Okay. IELTS, if you don't have a credit card, send us an email. We can help you out with a Western Union or bank transfer as well. Or you can also pay through PayPal on the checkout form. To send an email if you have questions like IELTS with fun, about our products or about the exam, send it to Adrian, my name, Adrian, at aehelp.com, and we usually get back to our communications in less than 24 hours. Hi Ava, good to see you. Haven't seen you in a long time. All right, hope you're doing well. You can get our books, our exam books, also from Amazon in hard copy or soft copy electronic. Just search for AE Helps Academic IELTS or GE Helps General IELTS. Today reading, tomorrow we will finish the task 2 we started earlier today for the members. Then we'll do a listening tomorrow and more classes on Saturday. Let's get to our reading passage. Boom, explosions in space, supernovae. You just turn the page from passage 2 in your exam. In fact, you should have seen this already because you should always look at all 3 topics and choose the easiest one. Explosions in space, supernovae. What are we looking at here, students? I'm doing very well, Ava. Thank you for asking. Summer is beautiful here in Hungary. As you probably know, weather is warm and lots of fun activities to do. All right. Abdullah Al-Mamoon, you couldn't comment on the previous video because that was for a members chat only setup. So only members can chat in those videos. Adam Tang says, that is an exploding star. Quite possibly. Could be something else. But you're right, Adam. It's an exploding star. Fabian, that's a little bit off topic. You have a stuttering issue. Yes, it would affect your exam, but you can explain that in your application that you have a stuttering issue. So pay attention in your application. All right, so explosions in space, supernovae, yes, exploding star. I'm just being a smart guy. It could be also exploding stars, right? There's 2 types of supernovae, Adam. So it could be an exploding star or exploding stars. All right. So I'm looking here at this picture. I'm looking at the title, Explosions in Space, Supernovae. What should I do? So my goal is to get a high band score. I want to get as many answers correct as possible in this reading. What should I do? What is my next step here after reading the title and looking at the picture? Jibin says, a star explodes at the end of its life. Farhan says you should visualize a big star exploding in space. It's very bright. Absolutely, visualizing is a good idea. Santa says maybe check out the questions, read them. Just don't read ones that have extra or false information. Sure. Yeah, and if you figured this out, you can do a bit of critical thinking first. So what is a supernovae? It's a dying star. It's an exploding star. Why does it die? Well, it's very old. It explodes. And how? We're not scientists. Maybe we don't know the answer to that. So let's go to the questions. Here are the questions. So reading passage 1 has 5 paragraphs. Which paragraph contains the following information? Write the correct letter A to E in boxes 27 to 32 on your answer sheet. So here you have to match the paragraph with the information, or you have to match the information with the paragraph, said another way. Should I read this kind of question before I read the passage? So Jay Patel is asking, do we have to read the questions first? Some of them, Jay Patel, some of them. This one, Sana, Pachu, and Hung say, yes, you should read this. Sure. Why? Why should I read this question before I read the passage? Why? Why should I read this question before I read the passage? What's the logic? Reba says, no, first you have to read the passage. No, you can read this question, especially if you're doing the paper-based. Pachu says, because all of this question or all of this information is somewhere in the passage. Yeah, Hung agrees. This contains information. Farhan says, it's all relevant. This is all in the passage somewhere. And it helps you to get an idea of the passage, okay? So think about that, all right? So here we go. 27, mass energy conversion. So let's read it together. 28, the requirements for a type 1a supernova. Supernova as intergalactic measuring sticks. Heavy elements come from supernovae. The fuel used for stars. Supernovae are the progenitors of much of existence. All right, so I just read all this. What have I learned? What information, in my own words, what information have I learned about this passage or about supernovae just by reading these questions? What have I actually learned? You should always actively read these, so try to understand it. If you don't understand all of this, it's fine. Like if you don't know what a type 1a supernova, it's fine. But I've learned that there's a type of supernova called a 1a, okay? Maybe I don't know what progenitors means, so I don't worry about that, okay? But here, the fuel used for stars. So I learned that stars burn some kind of fuel, okay? So Farhan says something about causes, eruptions, emissions. Okay. Well, I've learned that they change energy or convert energy somehow, right? I've also learned that heavy elements come from supernovae. Sure. Okay, so some useful information there for my reading. Okay, let's look at questions 33 to 36. Complete the sentences below. So this is a sentence completion question. Should I read this one before the passage? Choose no more than 2 words from the passage for each answer. Is this question type a good one to read? Farhan says, yeah, review this one, sure. Absolutely. It's a good one to read. Again, all of this information is somewhere in the passage, okay? You only avoid questions that have extra or false information like true, false, not given, or matching sentence endings, okay? So now I see a lot of yeses from Rahul, Charlie, George, Satisfying Times, Alvina, Supun, and Rajinder. So that's great. Yeah, read this one. Let's read it together. Type 2 supernovae originate from a star which is. The energy producing process in a star converts something into something. Okay, sure. The death process starts when all of the hydrogen is used up. The star begins to process something elements. The first element that can no longer be fused into another element is something. Okay, good. So here I read this information actively. I paid attention. I skimmed it over. What did I learn now? So if I think about this information, I haven't read anything from the passage yet. I just kind of quickly read over this information, paying attention. And I, of course, don't forget that I read this information here also. What is one quick piece of information that I learned which is valuable for my reading? Can anybody read my mind? What did I learn? Satisfying Time says the origin of supernovae. Yeah. Santa says some of the gases that they emit when they die, so something about hydrogen. Sana says something more about the elements, right? The energy source of supernovae, right? Satisfying Times, hydrogen, right? So we learned about that. So it says the death process starts when all of the hydrogen is used up. Okay, and then here, the fuel used for stars, maybe the answer to that is hydrogen. So that's an interesting or important piece of information. Pachu says you've also learned the types of supernovae. So here, in this one, I saw type 1a supernova. And of course, paying attention, I realized that here, there was something about a type 2 supernovae. Aha, so there's two types of supernovae. I already learned that, and I haven't read any of the passage yet. Students, you can learn a lot of valuable information from the questions when you read actively and you pay attention. Okay, so that's my first tip for you today when you're practicing the IELTS exam at home. So when you're practicing the reading section, the questions can help you to understand the passage. Know the correct way to use the information from the questions and read them actively with critical thinking. Okay, it's very useful. All right, now here we have some more questions. Okay, we have more questions. Satisfying Times. I'm going slowly. So you're saying, there's no time for this, Adrian. I'm going slowly, but if you train yourself at home to read over the questions quickly and focus your mind on making connections in the information, you have time for it. I've seen many, many students at band 6.5 and 7 do this very effectively in the 20 minutes, okay? So I only teach you strategies that I know will work for a band 6.5, 7 or higher student, or 5.5 even, when they're practicing at home. But the trick, Satisfying Times, is you have to practice at home. If you go into the exam and say, hey, I'm going to do what Adrian was showing in class, guarantee you'll run out of time. Absolutely. You need to practice this at least a dozen times at home first. Okay? All right, here we go. Some more questions. 37 to 40. Multiple choice. Those fun MC questions. Should I read this information? Should I read that? So is this one of those questions where I can say, oh, that's some good information there, I should read it? No. So some of you are saying, only the questions, only the questions. Yeah, only read what's actually in the passage. So we don't know the answers. We don't know what's in the passage, what's not in the passage. So just read the questions. The sun will not become a type 1a supernova. Why not? Okay. Next question. The Chandrasekhar limit is... If two type 1a supernovae are observed and one is brighter than the other, what can be concluded about the dimmer one? Supernovae can be compared to something. Okay, now, satisfying times. So far, this should only take me what we've done in the real exam, like 1 minute. Okay, maximum 1.5 minutes. All right, now I go back and I read. So let's read this together. And at home, you have to practice active reading. Okay, and I'll show you what that means. So I'll show you what active reading means. Okay, don't mark the questions first, Abdullah. It's a bad idea. Okay, it can be very confusing. All right, so here we go. Read with me. This is a passage 3. If you try to just search or skim read for answers, you will not be able to answer most of the questions. All right, here we go. Read with me. Starting from here, from supernovae. Supernovae are among the most spectacular events in the universe. Now, you probably think I'm reading slow, but I'm not. It's okay to read at this speed. Read aloud with me. Okay. They are incredibly powerful. In just a few weeks, they can release the same amount of energy as our sun will release in its entire lifetime. Supernovae are also the origin of many of the elements that make up the universe. Most of the elements of the periodic table require enormous amounts of energy to produce, and supernovae are the only source of this energy. Due to their consistent brightness, supernovae are used to measure large distances across the universe. What is this paragraph about? So what is this paragraph about? A, at home, you should always practice active reading. The only way to get the high scores in the IELTS exam is with active reading. Practice at home, or the same luck as it takes to win a lottery ticket. I think you should go with the first one, not the second. So active reading means to ask and answer the key questions of what, why, and how. For each paragraph, train your brain to think like this. So what is paragraph A about? Okay. Hung says, what is supernovae? That's what it's about. Pachu says, supernovae releasing energy. Rahul says, how supernovae are different from the sun. Mohammed Wahab says, introducing supernovae and their origin. Yeah, it introduces and defines supernovae, right? That first paragraph introduces and gives a definition for what supernovae are, right? Why? Why does it introduce this spectacular phenomenon? Okay, why? So why does the author introduce this fantastically spectacular, powerful phenomenon? What's the idea? Adam says the article always starts with an introduction. Absolutely, Adam, as does every good, well-written essay. Okay? Rahul says to understand the basics about supernovae. Jay says to understand the paragraph, not just Jay Patel, but you're on the right track. Okay? To give an idea to the reader, because people don't know about supernovae, says Amarjeet. Hung says to understand the origin of supernovae. Adam says to tell the reader what the article is about. Adam, even a little bit more than that, to give an outline to the reader about the essay. Okay? So the introduction gives you the outline. A good introduction should always give you the outline and tell you basically what you are going to read and even the structure of what you're reading. So what the next paragraph or information will be, what will come after that, what will come after that. So it gives an outline to the reader about the essay and explains that supernovae are very important as sources of immense energy and elements. Okay, so that's why it tells us that, to give you an outline and to explain that they're super important as sources of immense energy, right? Okay, you need to practice understanding what you read at home. It's not as tricky as you think. You just have to focus and ask these questions. So if I look at the passage, again, if I look at this paragraph, this introduction, what will I read about first? Let me just, for those of you who want to look at the next paragraph. So they are incredibly powerful. In just a few weeks, they can release the same amount of energy as our sun will release in its entire lifetime. Supernovae are also the origin of many of the elements. Most of the elements of the periodic table require enormous amounts. Supernovae are the only source of this energy. Due to their consistent brightness, supernovae are used to measure large distances. So what will the paragraph talk about first? We'll probably talk about the energy of supernovae and their lifetime. What will the the essay, what will the essay talk about first? Their energy, their lifetime. Then what will it talk about? It will probably talk about the elements that are created by supernovae. What will it talk about after that? So after it talks about the life of supernovae, after it talks about the elements of supernovae, what do you think the essay or the passage will talk about after that? Okay, so after it talks about their life, their energy, it talks about producing the elements of the periodic table. What do you think the passage will talk about after that? Sana says there are different types. The different types might be the different lives of supernovae. Parvanthi Raju, very good, says, well, somewhere near the end, it will probably talk about their brightness and how they're used to measure distances. Okay, good. Why is that important? So why is it important for me right away? And Satisfying Times, you'll like this because I know that you and many students are worried about not having enough time on the exam to finish reading. And this is passage 3. So you might already be short on time. So you're going to like what I'm showing you right now because it's going to save you a lot of time. Why is it important for me to actively pay attention to this introduction and figure out the setup of the passage. And some of you who are here from the beginning of the class should immediately go, aha, of course. This is what Adrian is trying to show me. So here's my second tip for today. Tip number 2. To be quick and effective, in answering questions, you must identify the structure of information using the introductory paragraph. This can really help you with locating information for questions, especially matching information to paragraphs. Okay. So remember our questions, students, from the beginning of class? Remember the first set of questions? It was, which paragraph contains the following information? And then it says mass energy conversion. Now, according to the introduction, where do you think I will find this? In the beginning, middle, or the end? Probably somewhere near the beginning, okay? The next one, the requirements of a type 1a supernovae. Where will I find that? Well, somewhere around the beginning or the middle, okay? Number 29, supernovae as intergalactic measuring sticks. Where do you think I will find that information? Number 29. Number 29, according to the introduction, so without even looking at the passage, where do you think I'm going to find supernovae as intergalactic measuring sticks? Satisfying Time says, well, probably somewhere near the end, because that came near the end of the introduction. Absolutely. So that's a quick tip, Satisfying Times, of how you can speed up your comprehension and your ability to answer questions. And for those students who are running out of time, like let's say you used up 50 minutes of your reading, which you shouldn't do, but you used up 50 minutes for passage 1 and 2, and you only have 10 minutes left for passage 3, this strategy can help you to save a few more marks for passage 3. Really focus on the introduction and then just jump to the questions and look for those parts. Okay? So that can help you in a panic type situation. Okay? Focus on the introduction to help you identify the content of questions. All right? Okay, so let's go back. Now that's obviously in a panic situation, but in an ideal situation, you have 20 minutes so you can read and comprehend. Okay, all right, here we go, students. So let's read these together. We'll be a little bit more fluent now. I will verbally ask you what, why, how, but not write it down. Okay, here we go. So B. There are two major types of supernovae, type 1a and type 2. There are a number of differences between the two, but the main difference is the process by which they come into being. Type 2 supernovae originate from a dying star. A star begins to die when it runs out of fuel. Fuel for stars is the element hydrogen. For their entire lives, stars fuse hydrogen into helium, producing energy in the process. This energy comes from the difference in mass between a helium molecule and the 4 constituent hydrogen atoms. Now here you're thinking, oh, that's tough. I'm trying to learn about chemistry in English. Don't panic, okay? Just read and understand as much as you can, okay? 4 hydrogen atoms have a mass of approximately 4.0318 atomic mass units, while a helium atom's mass is approximately 4.0026 atomic mass units. The difference between these two values is the amount of mass which is converted into pure energy. In a dying star, there is no more hydrogen. All that is left is helium. At that point, the star begins to fuse helium molecules together to form carbon molecules. Once all the carbon is gone, the star moves on to even heavier elements, and the star consumes these heavier elements at a faster and faster rate. A star may take 10 million years to consume its hydrogen, then take 1 million years to consume its helium, 1,000 years for the carbon, 3 years to consume the neon, 3 months for the oxygen, and only 5 days to convert all of the silicon into iron. There is a stopping point, however. Once the core of the star is entirely iron, there can be no more fusion. This is because the small difference in mass that is converted into energy is not present in the case of iron. The star is then left with an inactive iron core. Once the iron core reaches a certain mass called the Chandrasekhar limit, the star can no longer exist under its own weight and collapses in on itself. The result is a cataclysmic type 2 supernova. Students, what is that paragraph about? It's a long one, long paragraph B. What is this paragraph about? What is it about? Alvina says the difference between a type 1 and type 2 supernovae. Yeah, it says some of that at the beginning, Alvina. At the very beginning of the paragraph, it says there are 2 major types of supernovae. The difference is the process which they come into being. But then here it goes off with the type 2 supernovae and then talks about the type 2 supernovae for the rest of the passage. Amarjeet says it talks mostly about type 2 supernovae and how they come into existence, so how that happens. Yeah, so it talks about type 2 supernovae for the most part. Okay, for the most part, it's discussing how that happens with the burning of different types of elements, hydrogen, helium, and so on. Why? Well, to show the difference in a type 2 versus a type 1 supernovae. How? By explaining that type 2 supernovae burn different kinds of molecules or elements, and then they explode. Okay, here we go. Let's keep going. Let's get some fluency. Again, students, I'm not just reading for you. Hopefully I'm reading with you, together with me, students. So let's read together, okay? I'm not just reading for you. That would just be a listening class, but this is a reading class, so read with me. The other type of supernova is the type 1a. Type 1a supernovae are formed most commonly in binary star systems, where there are 2 stars which rotate around a common point. For a supernova type 1a to occur, one of the stars has to be a white dwarf. A white dwarf is the remnant of a low-mass star that has come to the end of its stellar life. Our sun will one day be a white dwarf because it lacks the mass needed to blow up in a supernova type 2 explosion. In a binary system, the white dwarf star gravitationally attracts matter from its companion star, with the matter taken from the companion star becoming part of the white dwarf. Eventually, the white dwarf will have added so much mass that it begins to approach the Chandrasekhar limit. Once it has hit this limit, just like type 2 explosions, the white dwarf can no longer sustain itself and the core of the star collapses. The star blows itself up in an even more spectacular event than a type 2 explosion. Rahul Hardas is asking, what's the Chandrasekhar limit? That's a very specific number that was identified by an Indian mathematician. You can look that up. It's a brilliant piece of science used for a lot of fantastic calculations. What is this paragraph about? Satisfying Time says it's introducing a type 1a supernovae. Indeed it is. Yeah. Okay. Pachu says the birth of a white dwarf and its explosion, which is the same as a type 1a supernovae. Why? To show the difference between type 1 and type 2. How? Well, type 1a are even more powerful explosions that are a result of a binary star system. So two stars moving around and around. Okay. Farhan says they even give the example in the how, right, that our sun will be a dwarf, a white dwarf star at some point. Okay, let's keep going. D, type 1a supernovae are extremely bright. If the sun were to be replaced by a type 1a supernova, it would appear 5 billion times brighter. Bring out your sunglasses, ladies and gentlemen. That's a lot of brightness. This brightness is also very consistent from one supernova type 1a to another supernova type 1a. This consistency has led astronomers to use supernova type 1a as what are called standard candles. A standard candle is used to determine how far away an object is. For example, if we observe a supernova type 1a in a nearby galaxy, we can tell very accurately how far away it is by comparing the apparent brightness of the supernova observed with its absolute brightness. Respectively, if the supernova is very bright, the galaxy is quite close. If the supernova is very dim, the galaxy is very far away. What is this paragraph about? What is paragraph D about? It is about... Just think about those questions. Mohammed Wahab says it's about the measurement. It's about using supernova type 1a as measurements, calculating distance. Heba Ahmed says correctly. It's about calculating distance using supernova. Farhan identifies it as light candles. Farhan, it's not light candles, it's standard candles. Okay, that's what it's called. It's standard candles. Very important if you're learning physics or some other sciences, okay? It's not just measurements in space, but it's type of measurement for distance. Absolutely. Why? Well, it lets us figure out where objects are or how far they are in space. How? Just read the paragraph, okay? Here we go. E. Supernovae are responsible for every element in the universe that is heavier than iron. Every atom of gold, silver, tin, and lead, as well as 80 other elements in the universe, was born in a supernova. Supernovae are also the origin of most newly born stars in the universe. Our sun, for example, was born from a cloud of dust and gas that was left over from a supernova. The Earth, likewise, was born from a supernova. It is not too imaginative, therefore, to regard the plants, animals, humans on this planet as a development of this supernova. Every atom of our bodies was once scattered in a supernova explosion. Therefore, many scientists believe that supernova are the crucibles of existence itself. Now, I'm assuming that some of you might think, well, maybe it's not a supernova, but it's God. I'll ask you this question. If I had to imagine what God looks like, that's kind of how I would imagine him or her or both. So supernova and God might not be that different. Anyway, that's just food for thought. That paragraph was about the conclusion and supernova being responsible for all of these elements, these heavy elements like gold, silver, tin, lead, and perhaps all of life itself. Okay, quite interesting. So a little bit of science and spirituality all rolled into one there. Let's answer the questions, students, based on our critical thinking. Here we go. So, yeah, Farhan could be. Absolutely. It could be it himself. We don't know that. All right, here we go. So, number 27, mass energy conversion. Okay, so which paragraph talks about changing or converting mass energy? Is it A, B, C, or D? So changing mass into energy. Okay, Kamlesh says it's B. Farhan says B. Reba says B. Yeah, absolutely, right? Remember, it's going to be somewhere near the beginning. We already talked about that. And here, this energy comes from the difference in mass between a helium molecule and the four hydrogen atoms have a mass of approximately, so that is the right answer. B. Okay. Number 28, the requirements for a type 1a supernova. Okay. 28, the requirements for type 1a supernova. First, it introduced what supernova are about. Then it talked about a type 2 supernova. Then it talked about a type 1a supernova. Then it talked about measuring sticks. Then it talked about supernovae, the origin of many of the elements. It's only 5 paragraphs, right? So this one was C. If I'm an active reader, students, if I'm practicing this at home and I'm an active reader, I can answer that easily and quickly without reading the passage. Okay. 29, supernovae as intergalactic measuring sticks. So B, C, number 29, intergalactic measuring sticks. Libyan Gamar says D. Hung says D because it was introduction about supernovae, type 2, type 1, measuring sticks, right? So again, I'm confident. Look at how many of you are answering D. That's fantastic. Okay, so a lot of you are now like, oh yeah, okay, that makes sense. Okay, number 30, heavy elements come from supernovae. Okay, heavy elements come from supernovae. Number 30. Muhammad Wahab says that's E. Satisfying time says E. A lot of you say E. Yeah, we talked about gold, silver, lead. Okay, so I want to show you again, or I want to emphasize for you that when you read critically and you pay attention and you know what you're doing and you practice this at home, you can answer questions without trying to search for all this information. 31, the fuel used for stars. The fuel used for stars. 31. Mr. Santosh, for the previous one, that was correct. Okay, Chutney, Katroja, and Hung, and Aryan Pudasini, Reba. Yeah, B, right? What is the fuel used for stars? Bonus question. Can you actually tell me what the fuel is instead of just telling me where it came from? Do you remember what it was? What's the fuel for stars? It was there. And I think a lot of you were very visual. You have a lot of good ideas. Okay, Mohammed Wahab says there's helium. It's one of them, Mohammed. Mostly the fuel is hydrogen, which Reba said. Hydrogen. Yeah, and that was explained in paragraph B. Okay, supernovae are the progenitors of much of existence. So the last one here, 32. Supernovae are the progenitors. Progenitors means the origin here. But even if you don't know this word, if you're like, I don't know what progenitors means, just read it without that. So supernovae are the something much of existence. You'll still get that it's paragraph E, absolutely. Okay. Now, for this question type, students, what we did here is a lot more effective than if you're skimming and scanning. If you try to search for this answer or these answers, and satisfying times, this is where I want you to be really careful. If you try to search for each of these, you might actually waste a lot more time than if you just read the passage actively, because you might have to reread the passage 2 or 3 times searching for one piece of information. Okay? Do you see what I'm saying with that? Satisfying times, like if I'm actually trying to search for these, I might get a couple of them very quickly, but then this one or this one, it might really take me a long time. I might have to do a second and a third read. I might get lost. So it might be a lot more confusing. Okay? Not might be, probably will be. All right? Okay. So let's have a look at the next questions. Here we go, fill in the blanks. Type 2 supernovae originate from a star which is... What's happening in a type 2 supernovae? The star which is... Keep it simple. You might not even have to search for that. Hung says dying. Farhan says dying. Chudney, you have a good idea, but... the word is dying, okay? Aryan says dead. The better word is dying here. Okay, dying. Yeah, dying. Not died, not dead, dying. So pay attention. Here it's just the grammar. If you realize that it's dying or dead, it's fine, okay? Number 34, the energy producing process in a star converts something into something. Now again, because we read this actively, we can figure this out. If I don't know the spelling, I can go back to paragraph B, right? So if I jump back to paragraph B, whoa, there I am. Okay. For their entire lives, stars fuse hydrogen into helium. Okay? So again, I can be very quick in this problem-solving process if I used active critical reading. Okay? Converts hydrogen into helium. All right? The death process starts when all of the hydrogen is used up. The star then begins to process something elements. Okay? A lot of you have hydrogen into helium. Hiba, Aryan, Rahul, Halmesh, Reba, Parvati, all the right answers. Okay? You don't need the into, of course, because you have that. So in your answer sheet, you just put hydrogen, comma, helium. Okay? This one here. The death process starts when all of the hydrogen is used up. The star then begins to process something elements. This is an adjective, okay? And we want to keep it simple. So after the hydrogen, yeah, Mr. Santosh says heavy, but the word form is wrong, Mr. Santosh. So heavy elements is almost right. It's not quite, though. Hung, very good. Yeah, heavier elements. Yeah. Heavier elements like helium, neon, silicon, right? Heavier elements. Okay? The first element that can no longer be fused into another element is, I hope some of you visualize that. What was that? What was that heavier element? The first element that can no longer be fused into another element is iron. Yeah, that's right, iron. Iron. Okay. I think that was kind of easy to remember, iron, because we're familiar with iron, hopefully, if you know that word. It's metal, right? Iron, metal comes from iron. Steel comes from iron. Okay? And that's quite different than thinking about helium or hydrogen or oxygen or silicon or neon. Okay? So again, I mean, if you have to search, you at least know which paragraphs you have to look for, right? So that's the good news. Hopefully, you can answer some of these. Again, students, for those high IELTS band scores like 7, 7.5, you should not be searching for every answer. You should be able to correctly answer about 60% of questions without looking back at the passage. Okay? That's the key. All right? Multiple choice, always try to finish on your own and then find the answer. Don't just search in the answers. So the sun will not become a type 1a supernova. Why not? Why will the sun not become a type 1a supernova? Don't search in the answers. Think about the answer. Hopefully you visualize this in the passage when you were reading. All right? So why? Why will the sun not be a supernova? Type 1a. Or sorry. Yeah, type 1a supernova. Actually, it should say, why will the sun not become a type 2 supernova? Because it will become a type 1. Or sorry, yeah, type 1a. Yeah. Why not? But you says it will not produce enough energy. Not true. Let's see. Not enough fuel. Nope. What do you need for a type 1a supernova? It's not going to be a type 2 either because it's too small. So it's too small to be a type 2. And it's not going to be a type 1a because it's missing something. It's missing its buddy. Okay, it doesn't have a friend. For type 1a supernova, you need 2 stars that spin around a common point. Okay, our sun doesn't have a buddy, right? Well, it does. It has little friends like Earth and Mars and Jupiter spinning around it, but it doesn't have another star friend. So C, it doesn't have a companion star. Any of you who said C, you're correct. Okay, C. It doesn't have a companion. It doesn't have a buddy star. All right. The Chandrasekhar limit is... What is the Chandrasekhar limit? It's a good piece of trivia to know, just in case you're on the show Who Wants to Be a Millionaire. The Chandrasekhar limit is the point at which a star can no longer hold its own weight, right? Don't just search for the answer. Be able to answer on your own, okay, from the passage. The mass at which a star will blow up, the distance, no, the time between fusing, the distance, it's the time that it blows up. Can't hold its own weight. Okay, so it collapses. It's got too much mass. So A. All right, couple more questions. 39. If 2 type 1a supernovae are observed and one is brighter than the other, what can be concluded about the dimmer one? So what can be said about the dimmer one? What can we say about the dimmer one for number 39? In your own words. Don't read. Okay? I'm going to hide the answers. Okay, there. What can we say about the dimmer one? You can actually see it on my... Yeah. The dimmer one is further away, says Reba. Reba says it's further away. Farhan says it's distantly located. It's far away, says Satisfying. Absolutely. Yeah, it's further away. B, that's why it's dimmer, because its absolute brightness is the same. Very good. Good for you, Reba. Thank you for answering my question. Heba, thank you for answering the question. All right, now the last one. Supernovae can be compared to, here we have to read, otherwise we don't know what's going on. So supernovae can be compared to the universe's factory, universe's graveyard, universe's hospital, universe's recycling center. What do you think? Recycling center, hospital, graveyard, or factory? The sun is born, it dies, it explodes, it's born again. Yeah, I would say recycling center. D is the best answer. D. Yeah, it seems like this cycle of birth and death among the stars is very similar to that which is among humans, animals, plants, mountains, the sea, the land. That cycle, that cyclical, beautiful, circular shape of existence. Absolutely. All right, students. That is a reading passage 3 from academic IELTS. That's about as difficult as it gets. Yes, it can be that difficult, and it can be even a bit more difficult in some cases. So be ready. Practice active reading at home. Remember these 2 tips that I told you today. Okay? When you're practicing the reading section, know the correct way to use the information from questions. Okay, read the questions that have information which is in the passage actively, and use those questions to help you understand the passage. So not just the passage to understand questions, but vice versa. Tip 2, to be quick and effective in understanding structure and locating questions, don't just skim and scan. Pay attention to the introductory paragraph, which gives you the outline for the structure of that passage. That's it for me for today, students. Tomorrow, listening practice, as well as task 2 completion for members. So make sure you're in class. aehelp.com for academic IELTS. Get all of our videos in high definition, no advertising, just beautiful live we have live, but we have pre-recorded HD videos, 6 original practice exams, and a fully interactive course with lots of tips and strategies. Again, the websites, they look like this, students. General one like this, click that red button to join. Academic like that, click that red button to join us there. Much love to all of you from Budapest, here in the heart of Europe. I hope you've enjoyed that class. Have a great rest of your day. Bye for now.